Hello all, just doing quick checks. I think everything is up and running. There's still a few people joining there, but we'll get started, I think. Thank you all for joining us for this webinar. It's about home energy upgrades and how to navigate the various grants that are out there and give you an idea of the various options that you have when if you're considering upgrading your home. Sound check. I think it's working. So my name is John Allen. I'm sales coordinator here at Ashgrove. Just to briefly what we'll be running through today, SAI's grants. The grants are all available through SAI. Their mission is obviously to assist or through incentivization or regulation to transition to a low carbon future. So to reduce the carbon output in various sectors. I suppose the sector we'll be looking at and why they give grants for this sector is the housing stock, to upgrade the housing stock. Ashgrove have been in operation since 2001. We do both new build and retrofit energy upgrades, I suppose, in retrofit and new build, obviously new energy systems. We've been working with SEI since 2006 on the various grant mechanisms that have been out there for renewable systems. We've over 16,000 systems in operation between the UK and Ireland. Last year, there was over 1,800 installations between design, install, QA, certification, and handover. We are a registered SEI one-stop shop, and we're also a Bord Gáis Premier installer for PV, so there's only 2 of those in the country. We're also energy aggregators, so it allows us to sell energy credits that are associated with your install, so we can give you a value for those as well. And we do all the grant paperwork in-house, so we have a specific grant documentation team that manages that. So a brief summary of our experience. You'd see on the left-hand side of the screen there is an apartment block that we did in London a few years ago. That was a full mechanical fit out. So from the energy centre, which was CHP, it had PV panels, pipework all the way up into the apartments, the heating in apartments, domestic hot water, full design, supply, QA that needed to be done for that apartment. So there was a lot of health and safety, obviously, and all that sort of stuff entailed in that. We have also done on the top right there, large houses within Ireland. So that's a large house with a number of pools, heating, cooling, all through heat pump systems. That's a ground source heat pump, so it's collecting energy from the ground as well as recovered energy from the ventilation from the pool areas. So quite a complicated project. And on the bottom right is an energy centre that we did in Scotland. In the end, it was prefabricated here in Ireland and shipped over to Scotland and assembled. That's a 1.2 megawatt or 1,200 kilowatts. Your average house is maybe 12 kilowatts, so this was 1,200. So quite a sizable system. We were taking energy from a lake in that case, so lake water, pumping it through the heat pumps. The heat pumps are also matched to tracking so that their electricity usage aligned with the electricity production from an on-site wind turbine. So that was a bespoke piece of software that we wrote specifically for that project. Very bespoke project, but all of this, not that we're trying to, or I don't think there's anybody who these projects will be of interest to, but I suppose it's just to give you a taste of the kind of the technical and project management teams that we have in-house here. We're capable of handling those types of projects, and we've been doing domestic projects since 2001. So just to give you an idea of the range of projects that Ashgrove have done and do. So onto your home energy upgrades and why would you do it? So the benefits of it. So the first one, I suppose, which is obviously a lot of people's main primary objective, is to reduce their energy costs. So that can be your gas bill, reduce the number of oil fills you have, and your electricity consumption. You do have a warmer home, which is a kind of a benefit that people probably don't appreciate until they have it. We've a number of people who've come back and said how their house is like a different house. They're using rooms in their house that they no longer used because they're now warm and usable, rather than having the sitting room and the kitchen maybe warm and every other house or every other room in the house slightly cooler. They can use the good room or the other sitting room because now that's up to temperature as well. So you do have a warmer, more comfortable home. Environmentally friendly, obviously, is very topical at the moment. Reduce your carbon associated with your house. That's the reason. Sorry, the environmentally friendly reason is, of course, the reason why there's grants going towards it. It's to reduce the carbon associated with the housing stock. Achieve a BER of B2 or better. Multiple benefits to having a higher BER, the value of your house and all that sort of stuff that we'll come on to, but it is an indication of how much carbon has been reduced in your home. So that increases the value of your home. Better air quality is an important factor as we're upgrading, we're insulating, and where previously maybe there was natural ventilation coming into the house through maybe slightly leaky windows, that will, depending on the measures you do, that will be eliminated. So ensuring that you've good air quality is one of the careful checks that we have to do when we're doing grant work to make sure that ventilation has been considered. Government-backed funding available. So if you're carrying out upgrades through One Stop Shop or CEG, which we'll get into in a while, or the BEH, you do get access to a low interest loan, which is obviously can be of huge benefit to people. And also on top of the low interest loan, which kind of funds the work or reduce the impact of the capital costs, there is also green mortgages available. So if you get up over a B3, you're into kind of green mortgage territory where you get a reduced interest rate than houses who have a higher BER, so maybe a C or a D. So the grants, there's a number of different grant options available. There's individual grants available if you wanted to do just one measure. There is the one-stop shop grants, which is more suitable if you want to do multiple upgrades. So maybe pumping your walls, doing an attic, and a heat pump and PV maybe. There's the community energy grants, which again is a multiple energy upgrade, but depending on your project, the one-stop shop or the community energy grant might be more suitable. The grant amounts are the same and the criteria is the same. The eligibility criteria is the same. It's only a different contractual structure. So they are two options. Fully funded energy upgrades then as well. We won't go through them today. There you can apply directly to SEI for those fully funded upgrades. It's only if you're on specific welfare payments that you qualify for those fully funded upgrades. So not everybody can apply for them, unfortunately. But if you do tick the box, it is worth applying. There is quite a long waiting list. I think it's 2 to 3 years at the moment to get those energy upgrades done. But they're working through that list. I know that's one that's dealt with, managed directly through SEI. Aside from these, there's the vacant house grant and the derelict house grant. So these are two grants which are, I suppose, the incentive of the top four there, the SEI grants, is to increase the energy efficiency of homes, reduce the carbon output of homes. The benefit of the vacant house grant and the derelict house grant, they're all got through the local authority. And the purpose of those is to try and bring housing stock back onto the market. So the old house that's been sitting there left idle, that you would cost you too much money to do it up. Now they're giving these grants towards it so that that house now becomes back on the market and reduces the number of houses that they have to build, I suppose. So just the vacant and derelict house grant, which is the Croí Cónaithe grant scheme, which is the last one I spoke about there. The vacant house grant part of it is 50,000. So to qualify for the grant, the house has to be vacant for 2 years, built before 2008. You have to live in one of the properties and you can rent out one. So if you've, we'll say, 2 houses that you've claimed a vacant and derelict house grant, as long as one of them is your permanent residence and the other one you're renting out, then you're okay. If you buy another house then and want to do the vacant and derelict house grant on that, you'd have to either not do it on the new one or pay back the grant on the one of the other 2. So you can't have three properties off it. You obviously need proof of ownership and or proof of active negotiations, I suppose. If you want to engage with them before you purchase the house, they're happy with that as well. These are all done through the local authority. So there's a housing officer in a specific vacant housing section that you can contact in order to get more information on these. The derelict house grant then is a top up on top of that. So it's a top up of 20,000. And that is available if the house is deemed to be derelict. So that is where the derelict house, sorry, there's a number of questions coming in there. I do have a colleague of mine logged in who can type answers as they're coming up. If I see them and if we can answer them as I'm going, I'll address it then. But feel free to put them into the Q&A box there. And as I said, I'll try and address them as I go, maybe come back to some at the end, or else my colleague will be typing answers. So sorry, I should have done that at the start. Going back to the derelict house grant, max of 20,000. So that's a 20,000 top up. So on top of the vacant house grant, so 70,000 in total. That does need to be deemed derelict by an engineer. Needs to confirm that it's derelict, or else if the property is on the vacant or derelict sites registered, then it also qualifies. Local property tax has to be up to date or exempt. Any other supporting documentation that your local authority may request. So on the vacant house side, I suppose the basic thing that they look for, the first starting point, is the ESB bills. If your ESB bills are low or non-existent, then they can kind of say, okay, this house has clearly been vacant for 2 years. So that's kind of the first starting point. There is scenarios where the ESB bills might be high. We've come across a number of scenarios where the vacant house is attached to a farm, and obviously the farm has a high consumption, so the bills that could be associated with that house now are high. There is other ways around that. Solicitors probably need to get involved, affidavits, that sort of stuff, and there is a site visit that the council come out, have a look at to make sure that it makes sense that the house has been vacant, that it looks like it's been vacant for at least 2 years. So the costs, I suppose the costs are up to the value of those grants, 50 or 70,000, depending on if it's vacant or vacant and derelict. The grants are up to that amount. So if the works only cost you 35,000, you'd only get 35,000 euro worth of a grant. They won't give you money. They won't allow you to profit from the grants, I suppose, is the long story short. This is all taxpayers' money, and this goes throughout, whether it's the vacant and derelict grants or the SEI grants. Because it's taxpayers' money, there's very careful, I suppose, rules that you're not profiting from it. So you can't do something that costs you 2,000 euro and claim a 4,000 euro grant for it. And that goes throughout all of the grant schemes. 13 months from approval, I believe that has been extended, or if not, it's about to be extended to 18 months. It is a problem that they identified, I suppose, quite early on, is that 13 months with the level of works that some of these vacant and derelict houses needed, it's quite a short time frame. They've extended it, or they are about to extend it from 13 months to 18 months. Now, in our experience, or what we're hearing from talking to them and from talking to people who are using them, they're quite happy to extend that, provided you show that you've made some progress. What they don't want is, they don't want to have that 50,000 euro ring fence for your project and you're now not doing anything, but they can't give that €50,000 to anybody else because it's been promised to you. So they don't want you sitting on it for 2 or 3 years, not doing anything, when somebody else could have used that 50,000 to update another house. So that's why there's time limits on any of these. It's all to do with budgeting and making sure the money gets used, as opposed to just people applying for it and not actually using it. So they are quite happy as long as you show that you're moving forward on the house. If you are, we'd say, 17 months into the build when the approval is 18 months, and you say, look, I need an extra 4 weeks or 12 weeks or whatever it is. Once they see that you've progressed and you are going to be finished in those 12 weeks, then they're kind of okay with it from what we're hearing. These grants and the SEI grants are also, they're quite keen to give out these grants. They're not trying to find ways not to give you the money. Provided you stay within the rules, they're quite happy to give it out to you. It's not like insurance companies where they're trying to find ways maybe to get out of making that payment. So people think that they're always trying to catch them out, or that there might be a hidden agenda in questions. Our experience has been very positive with SEI. Certainly in the last few years, they've been incredibly positive, and the vacant and derelict houses similarly very positive in terms of trying to get these houses back in the market. So the vacant and derelict house, you can avail of that along with the SEI grants. So that's an important factor. Now, you can't, going back to what I said about the profiting from grants, you can't claim the two of them at the one time. So for example, if you're claiming your windows through the vacant house grant, they don't really want to give you the windows through the SEI grants, because now you're getting two grants from two different places for doing the one works. So what we recommend people to do, I suppose, is use the vacant and derelict house grant for upgrading of structural work, kitchens, tiling, electrical work, all that sort of stuff, and leave the energy upgrades, so your dry lining, your windows, your floor insulation, your heating system, your solar PV, put that through the SEI grants. So again, it's very possible, just need to be slightly careful about how you do it. And also you can work with your local builder or whatever builder you choose for the vacant and derelict grant. The SEI grant, there's a little bit more to be careful of, that you in some elements need to be SEI approved, but in general you can use your own builder, provided you go through the right grant scheme. Small bit about heat pumps now, because heat pumps, I suppose, are the main focus of the SEI grants. There's quite a large grant towards it, one of the largest grants amounts there. Also, the eligibility criteria means that if you're putting in a heat pump, you're almost guaranteed to get in. So their focus is very much put on heat pumps. So just briefly, I won't stay too long on it, but just a quick explanation on how heat pumps work. So the heat pump uses 1 kilowatt hour or 1 kilowatt of electricity going into the heat pump, and that's to power the compressor and the fans and all that sort of stuff. It then uses that compressor and fan to extract 4 kilowatts from the external air. So those units that you see sitting outside the houses, what they're doing is pulling energy from the ambient air that's out there. And that means then that you get 5 kilowatts of heat out that go into your house. So you're only paying for one, you're getting these 4 free, and you're getting 5 into the house. So I suppose financially, first of all, what that results in is you're getting your 30 cent, or you're paying your 30 cent per kilowatt hour for electricity at the moment. You're getting 4 kilowatts for free, which means that each unit of heat is costing you 6 cent per kilowatt hour. So that's where I suppose the financial savings really come from with the installing a heat pump. Your cost per unit of energy is down at 6 cent per kilowatt hour. Whereas if you just had, for example, when you plug in your electric radiator, the portable electric radiator, that is putting in 1 kilowatt hour of electricity into the radiator, you're getting 1 kilowatt hour of heat out the other side. They're generally 100% efficient. So it's costing you 30 cent per kilowatt hour of that heat using direct electric heating. Why the grants are so leaned towards the heat pump is from a carbon point of view. Now, the similar ratcheting effect happens. So each unit of electricity has an amount of carbon associated with it. That's how much carbon it takes to produce that electricity using the coal-fired power plants, but also the more commonly now the wind and the solar and all that sort of stuff. So that's 250 grams of CO2 per kilowatt hour currently. Now, of course, you're only paying for one of those. There's only one 250 is associated with the 5 kilowatt hours of heat that you're getting out. So that means that each unit of heat only has 50 grams of CO2 associated with it. So it's much lower carbon than your direct electric heating. And that's because 4 of these are coming from the ambient air. An oil boiler, as a comparison then, if you put in 1 kilowatt of oil and your oil boiler is 80% efficient, you're only getting 0.8 of a kilowatt out the other side. So the rest of it is going up through the flue. And you'll feel that. You can feel that if you put your hand over the flue of your oil boiler, it's warm. So not all the heat that the oil is, not all the energy that's in the oil when it's burnt goes into your heating system. Some of it goes up to the flue. So in this case, if you're paying 12 cent per kilowatt hour of oil, that's about €1 a litre, roughly. You're then paying 15 cent per kilowatt hour of your unit of heat. So that's compared to the 6 cent per unit of heat that you're getting from your heat pump. Similarly, it's also 250 grams of CO2. I think it's 254 or something like that. I rounded it down for ease of figures of CO2 associated with each kilowatt hour. And the cost per unit of heat that you're getting is 312.5. So it's much more expensive per unit of heat, and there's a lot more carbon associated with it. So you remember from the heat pump, that was 6 cent per kilowatt hour of cost for heat, and it was 50 grams of CO2 per kilowatt hour. So better, more affordable, better cost for you. And from the SEI's point of view, or from the national point of view, I suppose, it's a much lower carbon. So that's the reason why heat pumps are being pushed much more than oil boilers or fossil fuels. Just some of the myths about heat pumps, and just to explain, I'll go through this briefly, but hopefully it's not too scientific. But again, this is how heat pumps operate in a real world scenario. So to heat your house, kind of a standard retrofit would be maybe 30 kilowatt hours per meter squared per annum. So that's how much heat each meter squared of your house would use over the course of the year. Obviously, down in summer, it uses 0 kilowatt hours per meter squared, and up in winter, it might use 40. But that's that's the average for the year. So if you have a 170 meter squared house, you've 5,100 kilowatt hours per annum is what your house will use. So that's the amount of energy that needs to go into your house to keep it up to, we'll say, 20 degrees as an average temperature. Domestic hot water then ranges from 1,700 to 5,000 kilowatt hours per annum. We'll take a figure of 3,200 just as a round figure. Obviously, that depends on how many showers you're taking, how long they are, but 3,200 is a fairly reasonable figure. So that means in total, the energy that your house needs is 5,100 kilowatt hours for space heating and 3,200 kilowatt hours for water heating. That's true in this example, if you like. How you generate those kilowatt hours is a completely different conversation. So whether you generate them with a heat pump, an oil boiler, a fire in the corner, whatever it is, that's how many kilowatt hours you need to keep that house at that temperature and to produce the hot water that you need. So after we've established that, the next thing is to do, okay, how do we produce those kilowatt hours as efficiently as possible? So an average efficiency of an air to water heat pump, we'd say 330%. So you'll have seen in the previous slide, we had a 1:5, so that was 500% efficient. An average we'll take as 330, including water heating and space heating. So that means that in order to produce the 8,300 kilowatt hours, we need 2,515 kilowatt hours of electricity to go into the heat pump. That costs you 30 cents, so that's roughly €755 per annum. If you were to use the oil boiler that we saw in the example, again, you have to produce the 8,300 kilowatt hours. You're multiplying it by 80% and by 12 cents then per kilowatt hour, you're getting €1,245 per annum. So roughly a €500 difference there in cost of an oil boiler over an air to water system. That's producing the same amount of heat. So whether, again, your 8,300 kilowatt hours is what you need to put into your house, how you produce it then is the next step, whether it's through an air to water system or through an oil boiler. There is a lot of bad press around heat pumps. A number of factors in here, poor heat pumps or badly designed heat pumps. This was, I suppose, particularly a problem a number of years ago when 20 years ago when Ash Grove started installing them, and maybe heat pumps was a slightly newer technology, but the systems were quite or could be quite poorly designed. In order to get the maximum efficiency out of your heat pump, you need to make sure that your heating distribution system is designed correctly. So it's not only the heat pump that's needed, the size of your radiators, the size of your pipework to those radiators, all needs to be considered in a heat pump system. Whereas with an oil boiler or a gas boiler, there's a little bit more forgiveness. There was probably a little less science that was needed in designing those systems. Whereas with a heat pump, it's quite a scientific exercise to make sure that it's right. And that was a lot of the problem in the transition between oil boilers and heat pumps. People were applying the same heating distribution systems for a heat pump as they would an oil boiler, and there's just a small bit more science needed. Another thing is they're just seeing higher electricity prices. So particularly over the last 2 years, if that price per kilowatt hour goes up to 30 cent or 60 cent, we'll say, then your output costs is doubled. So you have whatever that is, 1,400, 1,510 euro there of a cost there. Now, on the other side, electricity prices very rarely, if ever, go up without the oil boiler or without the oil prices going up. So that is another thing that we're seeing, whereas especially when prices started to go up, people were paying maybe 8 cents per kilowatt hour for oil. Then they put in a heat pump and the price of oil jumped to 16 cents per kilowatt hour, and the price of electricity jumped to 35 or 40 cents per kilowatt hour. And all of a sudden the heat pump was more expensive than the oil that they were using. But they're not taking into account that if they were using oil today, it would have been more expensive than what the heat pump cost them. So the cost of electricity and oil, your energy costs are, I suppose, they're not linked directly, but it's very rare that one will go up without the other or vice versa. Another thing we see, and this goes back to the comfort of the house, a lot of people use more energy because it's cheap. So you have a more comfortable house that you can live in, and you're more comfortable using that energy. So it's likely then that instead of using maybe 5,100 kilowatt hours per annum, maybe they want to keep the house slightly warmer than it was previously, and they need 5,400 kilowatt hours per annum. And obviously the heat pump has to generate that, so it has to be paid for. But they do have that warmer house. So that's another area that we see. I'll just take a quick drink. Questions are being answered away there. So the different grants that are available then, the individual grants or the BEH grants, you can see there on the screen the number of measures that are eligible for those grants. So heat pumps, attic insulation, solar PV or the solar panels, dry lining or external wall insulation or cavity wall insulation, they're all eligible. So if you want to just insulate your attic, for example, you can find an SEI registered contractor, apply for the grant yourself to SEI, get them to do the install, get the paperwork off them, and apply for the send in the paperwork to SEI, and SEI will pay the money into your bank account after you pay the contractor. So that's the kind of the most basic one. If somebody was just doing attic or just doing external wall insulation or something like that, makes a lot of sense. If you're doing more than one element, you can unlock the rest of these grants. So you can see the red X's here at the bottom, and the ones on the right hand side of that, there is extra grants available through what's called the CEG, the Community Energy Grants, or the One Stop Shop, the OSS. So these are extra grants that are available because you're doing, I suppose, larger works to your house, you're doing more things to your house, you can unlock these grants. And that's when people, I suppose, contact us. We see, is there a way that we can unlock these grants? Joe, you might was doing the windows anyway. Great. How do we fit you into this grant program? So there's quite significant grants there depending on the works you're doing. Floor insulation obviously is 3,500. Windows 4,000. These are all for detached houses. If it's a semi-detached houses, they go down a little bit. If it's a mid-terrace house, it goes down again another bit, and if it's apartments, it goes down further. So they're the extra grants that are available. In order to qualify for the Community Energy Grant or the One Stop Shop, your BER needs to improve by 100 kilowatt hours per meter squared. I'm talking an awful lot about kilowatt hours here. Apologies to anyone. It's an important, I suppose, factor from the BER. It's just a number from your point of view, and I'll go through it in a bit more detail, but that's something that we check for the CEG and the One Stop Shop. That's something that we have to check in order to make sure that it complies. As I said before, you can get the vacant and derelict grant as well as the SEI grants. You just have to be slightly careful about what you include in the vacant and derelict grant. So again, anything on this list, I would be leaving off the vacant and derelict grant if at all possible, and claiming them through SEI. So case study now of a one-stop shop project, and where I suppose we feel, Ash Grove feel, that they work very well. So these are houses inside in Mallow. We had done some of them before, and these people rang in then looking to get solar panels put up. We knew that the pre-BER was in around the C2 mark, which is a good mark for the one-stop shop. And we knew that we could get the 100 kilowatt hour uplift with enough, which I suppose a reasonable amount of measures. The other key metric is for the heat pump, the HLI, it's a heat loss indicator, has to be below 2. So that's the overall U value of the house, has to be at a certain level before they'll give you a grant to put in a heat pump. And that's going back to a fabric first approach, which is a critical approach and a correct approach. So again, these are numbers that we as Ash Grove need to be worried about. There won't be a test at the end where you need to know any of them. We knew, but from working on these houses, we knew that we could get attic, cavity wall, insulation, air to water heat pump, and PV panels. And we could do all that for €8,100 after the grants were taken into account. When they rang up first to get PV only at the time, it was coming in around 7,000. So for an extra €1,100 approximately, they got their attic insulated, topped up, the cavity wall insulation done, and they got a air to water heat pump installed and the same PV panels, and they got it all for 8,100. Now, what made that possible was the cost of the works was 25,000. There was €17,000 worth of grants. So we could do all this work and give them the cost net of the grants through the one-stop shop. If they went through the individual grants. So the BEH grants, they would have only got €11,400 worth of grants. So they're missing out on 4,600, 5,600, sorry, of grants. It's on the next slide, of course. If they went down through the BEH grants. And they brought their house from a C2 all the way up to an A3. So huge benefit from them. They didn't get the green mortgage then afterwards as well. So a lot of financial savings there. It makes sense for them. This was another house in the same estate. The only difference with this one is they got windows and doors and an EV charger. Now again, we did the attic cavity, heat pump, solar panels, windows, doors, EV charger for 15,000. So these have got a basically a full upgrade of their house. All the elements of their house upgrades. Their wall, apart from their floors, maybe their walls, their windows, their attic, all upgraded, and then the renewable energy put in the form of the heat pump and PV, and an EV charger put in there as well. When we have electricians doing PV panels, the EV charger is a quite a cheap thing to put in alongside it. So it can make sense to do it at that time. So these availed of €22,250 worth of grants. If they went through the BEH, they would have got 11,400, because you can't get the windows through the BEH grants or the individual measures grants. So there's a difference there of 10,850 if they went down through the BEH grants versus if they went down through the one-stop shop. The one-stop shop also allows for the homeowners to only pay the net of the grants. So all these homeowners had to pay us was the 15,100. We then did the works, I suppose, got the Postworks BER, submitted all the paperwork to SEI, and drew down the grants. So it was them who only had to pay the 15,000. Obviously, the cost of the works was 37,000. We had to wait whatever it was, the 4 or 6 weeks for the 22,250 to come through. So that's a fairly, I suppose, beneficial, cost beneficial exercise for the homeowner. They brought their house up to an A2, and again, they're in that green mortgage territory. So that's where a one-stop shop project really works, in our opinion. We're happy to do it. The homeowner is obviously happy to do it. There is low-cost funding available, which wasn't available when we did these ones, which they could spread that out over 10 years. So would make it even more attractive. This is a different type of project. So another case study, but this is not, you can see, I suppose, even between the difference of the houses here that are in the corner versus this house, you can see they're very different houses. This house is a vacant and derelict house, I suppose, to use the terms of the grants. Hasn't been lived in for probably 50 years or something like that. They're adding a big extension onto the back. They're redoing the whole house. Obviously, they're putting in new windows, doing something to the walls, big extension. As I said, this is a 2-year project. They are able to get the same grant amounts. They're obviously doing more work, so they're getting more grants. So in this case, they're getting €36,000 worth of grants. So they're getting all the heat pump grants, attic insulation, floor insulation. They were digging out the floors and putting in floor insulation. Your solar PV, external wall insulation they went with. They upgraded the windows and the 2 doors, mechanical ventilation, an air tightness test, the home energy assessment, and they got a project management grant as well. So that all came to 36,000, just over 36,000. So again, a sizable amount of grants. In this instance, it's works that they were probably doing anyway. The only difference is they're doing it to a very specific specification in this case in order to avail of the grants. So the important thing as well about the grants is technically the grants are all for upgrading this part of the house. You're not necessarily getting any grants for doing the extension. You can do the extension, but there's building regs there which force you to build the extension to a certain specification. The grants are there to make sure that you, or to incentivize you to upgrade the existing house to a certain specification. So that's the principle or the ethos of the grants in this scenario. What we do in this scenario is we give this spec to the homeowner, the builder, and say, this is what you need to do. So you need to put in floor insulation in the existing house. It has to achieve this U value. And to achieve this U value, you can put in 150 mil of insulation, and the insulation has to be of this thermal conductivity. Again, we go through all of this with the homeowner, and we're happy to do it with the builder. It's a specification that you need to do the works to. Once you do the works to that specification, you will get the grants. So these are checks that are done beforehand. People often say, how do you know that you will get to a B2 or you'll get the BER rating before we start any works? Well, we know from the drawings and from this house, the wall area of this house, and how much surface area of wall there is there. We can then say, okay, fair enough, the U value at the moment is very poor. It's 2, we'll say, or 2.1 maybe. We know that if we put 80 mil of dry lining on this wall, or 100 mil of external wall insulation on this wall, it'll bring it down to 0.27 or 0.25, we'll say. So now we can calculate the house as if it was finished, and we know what the BER will be at the end. So they have their own builder doing the extension. There's no benefit to Ashgrove coming in, bringing in our dry lining contractor to work along his plastering contractor, if you like, who's already on site, because now we have a mobilization fee, I suppose, or a mobilization cost for bringing those plasters to site and dry liners to site. The builder also has a mobilization cost for bringing his plasters to site. So there's no benefit of having two contractors on site doing the same thing. So by going through the community energy grants or the CEG, that allows you to use your own builder for it, who can stick to this specification, and then give us the paperwork at the end, and we can then draw down the grants for you. And that is another difference between the CEG and the one-stop shop, the community energy grants. The one-stop shop, obviously the homeowners only pay the net of the grants. The community energy grants, the homeowner gets the grants back at the end after the works are done. And there's applications that go in, and then once we receive the money, we pass the money on to the homeowner. I suppose the reason for that is, with these projects, there's probably a 2-year project. The one-stop shop examples we looked at, the works, I suppose, could in theory be carried out in a week, 2 weeks. In reality, it takes a little bit longer than that, but we're waiting that long to get the grants from when we start spending money and doing the works. We're waiting until we've the post-works BER done, the grant application made, and SEI pay the grants, until we get fully paid. Whereas with a community energy grant or a house like this, there's a lot longer. It could be 2 years before we're able to draw the grant down from SEI. And I suppose we're not a bank. We can provide, we can't provide finance, but in theory, if we provided finance, all we'd be doing is getting a finance from the bank and passing the cost of it on to you. So this is a much more efficient way of doing these types of projects, where you get the maximum benefit of the homeowner or of the grants without incurring additional costs for extra project management or extra mobilization fees or extra finance fees. The community energy grant is really the way to go for those types of projects. So one-stop shop or CEG, this is, I suppose, Ashgrove's opinion, I suppose, important to reiterate. When to use a one-stop shop? When there's nobody else on site, there's no potential conflicts with contracts. So you don't have, if you had a problem with the house, you don't have the builder saying, oh, well, Ashgrove did that part, and Ashgrove saying, oh, well, the builder did that part, or who's responsible for the joining between the two. when you've one builder building the house, you know, you can go back to them and say, it's your problem, you sort it out. So when you have two builders, which is essentially if you had a one-stop shop upgrading the front part of the house, as we saw there, and another builder building the extension, there is a huge potential for contracts. And either way, even if we did use the builder for the works, we would have to have a contract with the builder, we'd have a contract with the homeowner, and the homeowner and the builder would need to have a contract, and all of a sudden you're into three-way contracts and you need a solicitor, which also adds extra costs. Less than 2 months long, again, this is just a kind of a ballpark that we use. If the works could be done in that length of time, then it's a good fit for a one-stop shop, going back to the funding issues we discussed previously. No other works other than grant works, again, going back to the conflicts. If you're those houses in the estate in Mallow that we looked at, where they got done for 8,100, they were living in that house. They stayed living in the house while we were doing the works. There was nothing that disruptive that prevented them from living in the house. I think they might have been without heating for one night, but we just gave them electric heaters for that one night, and it was during the summer anyway, so it kept them warm. But there's no reason why you can't stay living in the house when you're doing the one-stop shop, I suppose, upgrades. When you're into the community energy grants, you're probably into the house we looked at there, the derelict house. There was nobody living in that anyway, so the amount of works they're doing, you wouldn't be living on site through it. So when to use a CEG or the community energy grant? If you have a builder already, as I said, there's no point in getting a second builder in there, which is basically what a one-stop shop would be. If you're doing an extension, again, similarly, you have a builder or you have an architect engaged already. If it's over 2 months, again, this is these ballpark figures that we use just to give us an idea of what works and what doesn't work. And if you're doing works other than grant eligible work, so if you were even knocking down internal walls, you'd still need a builder for that, and there's that coordination issue which could occur. So briefly, there is a loan scheme available for funding for the homeowner, so funding for that element. It was only released in April. It's claimed based on you drawing down the SEI grants. So when you apply for this loan, you actually give your MPRN number, and attached to that MPRN number, SEI also draw down the grants as well. And once those grants are drawn down, the SCBI, or the Strategic Banking Corporation of Ireland, they see, okay, this home got this loan, the low energy upgrade or the home energy upgrade loan. They also drew down SEI grants, so therefore we can say that, yeah, that loan was used for the correct use. So they're happy to give the low rates for that. So they start down as far as 3.55%. There's a number of banks on the market now, AIB, Bank of Ireland, and Permanent TSB. Flexible terms from 1 to 10 years, so you can spread it out up to 10 years. You can put it shorter if that suits you better. The loan amount is between 5,000 and 75,000. 75% of it must be spent on eligible measures. So you can claim up to 25% of the loan for doing other works. It's supposed to be for, I suppose, repainting or retiling or stuff like that. But it's at least 75% of the amount that you claim needs to be for the energy upgrade aspect of it. They're unsecured, so there's no charge taken over the property, which is the case with a mortgage. And as I said earlier, you must undertake one of the energy upgrades through the SEI program. So that can be through the one-stop shop for the Better Energy Homes or for the community energy grants. So that the Better Energy Homes excludes solar PV, unfortunately. I think solar PV seems to be doing well without this loan scheme incentivizing it further, so they've excluded that from it. But if you're doing attic or cavity or a heat pump through Better Energy Homes through the individual measures, you can use this loan scheme. They'll be available till December 26th. We probably see them being extended, I'd expect, provided there's no major problems with them in the meantime. So that's just another method of showing the same thing. You contact a one-stop shop or an energy partner or a community coordination or community and project coordinator to plan the energy upgrade. Once you've decided on what you're doing, we'll fill out a summary report. You can apply to that to any of the banks that are signed up for this scheme. They'll get your review the low cost flexible loan, and then they approve the loan, and then you can start the works. So again, with grants or with this loan scheme, it's all around the premise that you should have this in place before you start any works. So again, to go back to the philosophy of it, it's there to incentivize people to do things as opposed to rewarding them for stuff that they're already doing. And that's just the philosophy of it. That's not the rules. They won't say, oh, you've actually knocked down 2 blocks you've started already and therefore you're not eligible anymore. But they don't want you to have half of the house upgraded and then go, oh, I'll apply for grants here now. And then the grants, you were obviously doing the works anyway, so the grants would have no impact on it. So I'll just go briefly into the eligibility for the CEG and the one-stop shop. You'll have heard me mention the BER a bit, and this is how they measure eligibility. So it's all about the BER rating. So the first thing that we have to do is to get a BER and a technical assessment if you're getting a heat pump. Unfortunately, there's a cost associated with this, but it's the starting point to see where your house is at. So, and the reason this is so important is the target for SEI is to have as many houses as possible in this B2 and above bracket. They want to make sure that you finish at a B2. If you're already quite high, then they don't really want to be giving you extra incentives to do works to your house. If your house is, so they've put I suppose, drawn the line at a B3. So if your house is B3 or below, then you can qualify for the one-stop shop or CEG grant. If your house is B2 already or B1 or A3, they don't really want to be spending taxpayers' money on getting you to bring your house up to an A1. It's quite good already. It's above the SEI targets, so they don't want to be spending money on that. What they want to be spending money on is people who are in this bracket or lower, and making sure that they then get up to a B2. So the max starting point for the grants is a B3. So if your BER is higher than that, you aren't eligible for the one-stop shop or the CEG. You are eligible for the individual energy grants, and that is I suppose without the bonus grants that are out there, but you can still get some grants. You have to get up to a B2 once you're completed. So again, that calculation has to be done before we start, and can be done before we start to check to see, okay, I know if you put 80 mil insulation on your walls, upgrade your attic insulation to 300 mil and put in a heat pump, I know you'll be at a B1, for example. So we can do that calculation to start with. You also have to get 100 kilowatt hour uplift. So it's 100 points. Along the left-hand side of your BER, that's your kilowatt hours per meter squared per year that your house is using. So any house that's using between 175 and 200 kilowatt hours per meter squared per year, that's deemed to be a C2. That's done by, I suppose, using default measurements based on the year of the house. Any certs you have for U values, anything like that, is all taken into account. And that house that we'll say starts at 180, is a C2 must come up to at least 80. So you're achieving your 100 points better off, but importantly, they're also getting above a B2. So if we had a house down here that was maybe between 380 and 450, which would be an F. So if we had something at 400, it can get 100 kilowatt hours uplift. We'll bring it up to 300, but it's still well below our B2. So it still needs to get to the B2. So for a house that's down at 400, that'll actually need to get a 300 kilowatt hour uplift in order to satisfy the B2 criteria. So those two have to be met in order to qualify for a one-stop shop or a CEG. The heat pumps, going back to them, if your house is has a heat pump put in, you're almost guaranteed to be a B2. I haven't come across a house yet that has a heat pump in that's not a B2. So that's nearly guaranteed. On the other side of that, if you did get PV, so we say your house was a D2 and you got PV put in under the individual grants, that might bring you up, depending on the size of the PV system, up to a B2 or a B1, which would actually rule you out from getting the one-stop shop or the CEG grants. So I suppose the sequence in which you do work can be important. We've had a number of people call, unfortunately, where they've got PV from another company and said, okay, I want to look at doing the one-stop shop now. But in actual fact, the PV has brought them up too high in order to be eligible for the one-stop shop or the CEG. So important to consider. I suppose we sell PV as well, and we're very careful when we're talking to people that if you're thinking of doing other works or if you're thinking of changing your windows or something like this, PV only, that grant mightn't be the right one for you. Worthwhile checking if you can get other grants for the windows or for the other works that you're doing. So the higher the BER is on your existing house, the harder it is to get that 100 kilowatt hour uplift. So you imagine if you're at 127 or 130 there, you'd be a B3, you'd be between the 125. You have to get right up to being an A2 house, which depending on the type of your house can be expensive. So the other criteria then is around the heat pump. So as I said, if you are getting a heat pump, you are almost guaranteed to get to a B2. Part of that is because the heat pump is efficient, but part of that is also that you'll only get a grant for the heat pump if your insulation levels are at a certain standard. So they don't want to give people a grant for putting in a heat pump without the person having considered that their fabric is at the right level. So fabric first approach, you'll hear if you go onto SEI's website, that is a key criteria for them in order to make sure that, yeah, the heat pump is great, but if you can stop heat going out, that is the first protocol to make sure that, yeah, your heat pump is now operating efficiently and your renewable energy is not masking your heat loss of your house. So the HLI being below 2, again, that's a number that we need to worry about, not E. It can be between 2 and 2.3 in certain circumstances, and an SR50 is also required, and this goes back to well-designed heat pump systems. So for every heat pump that we install, we have to do a room-by-room analysis of how much heat each room is losing and how much heat the radiator in that room can produce at the temperature that the heat pump operates. So that's to make sure that, again, that your heat pump can run at its optimum level, that it's not working too hard. So first step is the BER. I just run through some of the documents that what a BER document might look like. That's the BER cert, which I suppose you'll all be quite familiar with. The rating there is highlighted. In this house, it's a D2. You'll see below that D2, there's 267.03, I think, kilowatt hours per meter squared per year. So that's what's deemed that it's in the D2 category. So this house, if this house only got 100 kilowatt hour uplift, it'd be 167. So it'd still be up at a C1. So this house has to get to the B2. So it'll have to get 100 and whatever that is, 50 kilowatt hour uplift in order to get to the B2. Advisory report, this is standard report that's automatically generated, apologies, with the BER when it's calculated. The dwelling report, which is what we want to see in here, the dwelling report is 14, 15, 16 page document with all the inputs for the BER, which allows us then to recreate this and to look at it and say, okay, we can see the U value for the walls are currently 1.1. If we insulate those, we bring it down to 0.27. What happens to the BER and what happens to the HLI in that instance? So the dwelling report is an important document for us in order to get that. And this is technical assessment document. This is a 4-page document, which is specifically for heat pumps. It's a requirement for SAI for any heat pump grant that you have this document done and completed. So it's based actually on the BER data that they put in. So anybody who's doing a BER, if they're a registered technical assessor, they can go this next step. There is an extra cost with it, but they can go this next step to do a technical assessment. You do have to be a registered technical assessor. Not all BER assessors are registered technical assessors, but all technical assessors are registered BER assessors. The cost for getting a BER and technical assessment done ranges on the size of your house. You can imagine if it's a 100 meter squared house, or if it's a 400 meter squared house, there's a lot more work involved in the 400 meter squared house. It can range from 500 to 700 euro, roughly. So how our process works. When people call our office, our first step is to find out, should we recommend you to get a BER and technical assessment? As I said, there's a cost associated with this, unfortunately. The BER has to be done by an external third-party person. One-stop shops or in-house can't actually do it because they're worried that we'd be biased, that we'd make it say that every house is suitable for a heat pump or whatever. So it has to be an external third party that does it. We have a number of ones that we work with regularly that we're happy to put you in touch with, and we're allowed to put you in touch with, but you can deal with them directly. So the first step when somebody calls in is to find out, should we recommend that they spend that money? So we have ask you a couple of questions basically to try and let us get a bit of a picture of your house. And then we can say, okay, you might comply by doing your attic cavity heat pump, and I'd expect the net cost to you to be something like 8,000, or you would have to do your windows, and we estimate that your windows might cost 15,000. So just to give you a ballpark, we might be wrong in some bits of it, but we've, I suppose, a lot of houses seen, so we try to give the best advice we can. But that's the purpose of that initial kind of questionnaire and discussion with our analysts, is to try and see what would we expect that you would need to do to the house. And then I suppose if that's a level of works that you're happy with doing, oh yeah, I was thinking of changing the windows anyway. I think if you're changing the windows, you can fit in, and this is kind of ballpark what you'll be looking at. Then go away and spend your money on your BER and technical assessment. If we look at a house and say, look, I think there's no way that you're fitting in unless you change your windows, the homeowner might say, absolutely not, I'm not changing my windows. I changed them 15 years ago. There's no way I'm changing my windows. We can say to that person, okay, there's no point in you spending your money on a BER and technical assessment. It's highly likely that it will come back. There is 50-50 scenarios where obviously where we're not sure and maybe something might come back different. We try to give it the best advice we can in that free consultation to just see if it's the right thing to do. Once the BER and technical assessment is done, if you do go ahead with it, we'll then do an analysis of your whole house. The BER and technical assessments look at very specific elements. So that BER and technical assessor, they're, as I said, they're third parties. They are looking at the BER data and the technical assessment data and passing that on to us. we're then looking at it from a kind of a holistic grant point of view. It might tick the box for the technical assessment if you put on, we say 50 mil of dry lining on your wall. However, if you put 60 mil of dry lining on your wall, it might unlock €4,000 worth of grants. So that's the type of thing that we're trying to look out for, to see that you maximise the grants available to you. So that's in the proposal. There's a sales advisor that'll discuss that with you, go through it with you, any changes you might want to make. We'll check them for grant eligibility if it's possible to change them, and then adjust them. Contract agreement then, and we go into detailed design where we discuss what the I suppose nuts and bolts of the project, how the project is going to work, where the heat pump is going to go, where the PV is going to go, where the cables are going to run for them, all that sort of stuff. We then schedule the install and hand over the project to yourselves. So we do a number of these webinars and seminars. There's a number of heat pumps do's and don'ts. There also, a lot of them are available on our YouTube channel if you want to have a look at that. And yeah, you can find this on our website. If you click into the webinar section, and you can click on the date that suits you and register for that. I'm assuming most of you have probably done it for this already, but worth seeing if there's any other. We do update that every now and then with other webinars that we're doing, so worth keeping an eye on that. If I know I've gone over time now, but if you're happy to stay on, I'll just do a quick run through of how solar panels work. And the solar panels that are out there at the moment are also all produce electricity. The solar thermal side of it has kind of gone. The cost of the solar PV, the photovoltaic cells, has come down so much that that's the preferred option now. So in essence, what it does is the sun shines on the panels, they generate DC electricity, which goes down into an inverter. The inverter converts it from DC to AC, and the AC is plugged into your fuse board, and the electricity goes to whichever appliance is using electricity at the time that the solar is generating. So if your fridge is on, if your cooker's on, the TV's on, whatever's on, it will feed as much electricity as this is generating into those appliances. The other option that's out there is an eddy diverter, or a hot water diverter. That puts the electricity, if there's excess electricity that your fridge or your TV or whatever it is isn't using, it puts that water into your hot water cylinder to produce hot water. The other option then for storing it on site is battery. So the goal of any of these things is to save the electricity that you're producing through your solar panel system and store it on site somehow, or use it on site is the goal. And if you have to store it, store it. So obviously using it directly as it's being generated is great. Next option is to store it as hot water, which you'll be using later on. So that's great. Now your hot water system doesn't have to produce extra hot water. And the other option is store it in your battery, so that when you turn on the TV later on or whatever it is, and when your solar panels aren't generating, it can use that electricity from the battery rather than from the grid. The last resort is to send it back out to the grid, and you do get paid for that. You get paid a smaller amount than what you're paying coming in typically. So maybe you might get maybe 15 cent per unit for coming in, but you might be paying 25 or 30 cent. Sorry, paying the opposite way around. You'll be paying 25 or 30 cent per unit of electricity that's coming into the house, and you'll be getting paid maybe 15 cent, maybe 20 cent, depending on your supplier, for every unit that you're sending back onto the grid. Those rates are dictated by the supply of your electricity supplier. So they might say that, yeah, we're doing an offer now where we're giving you 26 cent per unit of electricity that you send back. Important thing to balance there is what you're paying for it coming in, because there's no point in paying getting loads of money for it coming when you send it out if you're paying loads for it coming back in. That's how it works. Batteries are probably the big thing for PV, if they're useful or not. Depends on the size of the system. You'd really want to have a fairly big system, certainly over a kind of 10 panels, maybe over 12 panels, depending on your usage. And then it's that battery, in order to pay for itself, you want to make sure that it charges and discharges as much as possible in order for it to be worth its while. We have a software. There's a webinar actually, I believe tomorrow at lunchtime on the solar. Check our calendar there. I might be wrong on that, but that will go into it in more detail, and what it'll show the pros and cons of batteries as well. But making sure that your battery charges and discharges as much as possible is the end goal for the battery, to make it worth your while financially. Just checking now. I think Connor has gone through a lot of the questions. I think I've answered the rest of them as I'm going. Thank you very much, everybody, for joining and for staying listening to me for this long. Yeah, have a good day.